I'm in Build in Muse Knoxville to complete building challenges to try to explore how strong magnetism is. When exploring with the magnets in the amusement kit, I can feel the strong magnetic force of the magnets as they push and pull, but I cannot see the force. Together, we can do an experiment so we can see the magnetic field around our magnets. Take a piece of white paper and sprinkle it with a little bit of iron filing. Spread out the filings with your finger so they're an even layer. What do you predict or think will happen when we bring the N and S, the north and south magnet, underneath the paper? Try for yourself and watch what happens. Do the filings create a shape that looks like a figure 8? The filings jumped to the poles of the magnet. The figure 8 shows the magnetic field that's around the magnet. The magnetic force is strongest at the north and south poles of the magnet, and that's why the filings are in little piles there. Explore how the iron filings react when other magnets from the kit are placed under the paper. Make a prediction if the size and the shape of the magnet will change how the filings react. Let's see if we can use the strength of magnetism to try a few building challenges with the items in the kit. Take the 16 marbles and explore with them. What can you create with them? Wow, the marbles are magnets. They have 2 poles and can attract and repel other marbles. Take a magnet and try to lead the marbles into making your favorite letter, number, or shape. I made my favorite shape, a circle. I wonder how large the circle needs to be before I can put a marble in the center and have it stay still and not become attracted to any of the other marbles in the circle. I predict that it will take 10 marbles before the center marble is not attracted to the circle. What's your prediction? Let's test our predictions. Each time a marble rolled 2 and was attracted to the marble in the circle, I added it to the circle. It took 15 marbles to make my circle before the center marble was not attracted to the marbles in the circle. Try creating other shapes and repeat this challenge using the 16 magnetic marbles. I wonder if we can build with materials that aren't already magnets. Let's create a structure like we did in amusements, STEM structures. From that lesson, we learned that a structure is an object made from several parts that can stand on its own. This structure's parts will be hex nuts. Can you build a structure out of the hex nuts? How tall will your structure be before it falls over? Wow, it's hard to balance the hex nuts on top of each other before the structure topples over. How many hex nuts did you use? I used 6 hex nuts before my structure fell. Let's try to make our structure more stable now with a new base for our hex nuts to rest on. Take a magnet with 2 flat sides and make it the new base. Now try building your structure on top of it. What do you predict will happen now that the magnet is the new base? Look how tall my structure is. Hex nuts are made of steel, one of 4 materials that are attracted to magnets. As the hex nut sits on the magnet, they start to get their own magnetic field, attracting the other hex nuts to them. This allows you to build a very tall structure. It will also allow you to make branches or arms coming out of your structure. What other shapes could you create? The magnetic field around the hex nuts are weak, but will stay for a little bit after you take them off the magnet. What would happen if my structure was upside down? What do you predict will happen? Try holding a flat-sided magnet in one hand. With your other hand, add hex nuts and try to build a structure going down. How many hex nuts are attracted to the magnet? Only 11 of my hex nuts are staying together upside down on my magnet. I wonder what I'll need to do if I want to add more hex nuts. I think I'll add another magnet to my first one. Let's try to add more hex nuts. The extra magnet is adding to the strength of the magnetic field that's around my hex nuts, allowing me to continue to build. In the next video segment, we'll explore how barriers affect the strength of a magnet. Continue on to the next video when you are ready.